Have you ever stopped to think about how an AI can dig through literally millions of files? We're talking PDFs, web pages, all sorts of messy data, and just pull out the one perfect answer you're looking for. Well, today, we're going to pull back the curtain on a real-world system that was built for a massive AI challenge to do exactly that. We're going to see how raw, chaotic data gets turned into a pure, intelligent answer.
All right, let's get into it. Here's our game plan. We'll start with the challenge itself. Then we'll follow the data on its journey as it gets cleaned up, indexed by two different AI brains, and finally, see how the system narrows everything down to find that single best answer.
So first things first, let's set the stage. We are not just talking about a simple Google search here. Imagine a gigantic, private collection of every kind of file you can think of. It's a true digital haystack, and our job is to find that one specific needle for any question you might ask.
And that really brings us to the core problem this whole system was designed to solve. How in the world can an AI find the perfect answer when it's buried in a million different files? You've got everything from basic text files and PDFs to these incredibly complicated nested JSON data files. It is a huge, huge challenge.
Okay, this flowchart right here is going to be our map for this whole explainer. Now, I know it looks a little complex, but this is the actual blueprint for the search system, and we're going to walk through it piece by piece. You see, the data starts as a raw mess at the top. It gets cleaned and broken down into what we call chunks. Then you'll see it splits down two different paths. That's the whole two brains idea we'll get into. And finally, the system brings it all back together, refines the results until we get that perfect answer at the very bottom. So let's start at the beginning.
So where do we even begin with all this mess? Well, the very first stage is all about preparation. You can't just throw a mountain of chaotic data at an AI and hope for the best. This step, it's kind of like a librarian meticulously organizing a giant, messy pile of donated books before a single one hits the shelves. This whole automated process is called ingestion and normalization. First, it just finds all the files, doesn't matter what kind they are. Then, it standardizes them, gives each one a unique ID so it can be tracked forever. It strips out all the junk, like website menus and ads. And, this is crucial, it finds and gets rid of any duplicate documents, because that's just noise that will mess up the results.
Okay, so the data is clean, but there's another problem. A lot of it is still way too big. Think about it, a 100-page PDF is just too much for an AI to digest all at once. So the system uses something called adaptive chunking. It breaks these huge documents down into smaller, meaningful paragraphs or sections, bite-sized pieces the AI can actually work with.
And this isn't just a random chop-up job. The system is actually really smart about it. It knows that a normal article needs to be chunked completely differently than a structured file like JSON. For regular text, it breaks it up into chunks of about 800 tokens. You can just think of tokens as words or parts of words. But for that structured data, it uses a sentence-aware method to keep all the related info together. It's all about keeping the original meaning intact.
So now we've got all these clean, perfectly sized, meaningful chunks of data. And this is where we get to one of the most clever parts of this entire system. To make all this data searchable, it doesn't just build one library, or what we call an index. No, it builds two totally different kinds right alongside each other. The best way to think about it is like having two super librarians. On the left, you've got the sparse index. This is your keyword expert. It uses a classic search algorithm called BM25 to find exact word matches. It's like a super fast, super precise, old-school card catalog. Then on the right, you have the dense index. This is your concepts expert. It uses AI to turn each chunk of text into a long string of numbers called an embedding. These embeddings capture the meaning of the text. This allows it to find related ideas even if they don't share a single keyword. And if we look back at our blueprint, you can see this exact split right here. Right after adaptive chunking, the path divides. Every single one of those chunks we made gets sent down both paths. It's cataloged by both our keyword librarian and our concepts librarian. This dual approach is really the secret sauce to the system's power. So we've got our data organized in two brilliant ways. But how does the system actually go about answering a question? Well, it doesn't just pick one of its librarians, it asks both of them. And then it uses this really clever multi-stage funnel to combine their strengths and find the absolute best results. Here's how that funnel works. The system asks both librarians for their top recommendations. It gets a list from the keyword search and another from the meaning search. Then it does this clever thing called fusion, where it combines those two lists.
This technique gives a massive boost to any document that shows up high on both lists. It's like getting a double vote of confidence. Finally, it takes this new, much better list and hands it off to a final expert for one last quality check.
This final check is called cross-encoder re-ranking, and it's by far the most powerful step. Think of it like bringing in the world's leading expert on a topic for a final consultation. This specialized AI doesn't just glance at the question and a potential answer. It reads them together, side by side, to really judge how well they match in every little nuance and context. Now, it's super resource intensive, which is why it's only used on the top few candidates, but this step is what guarantees that final answer is the absolute best one.
So why all this complexity? Why go through all this trouble? Well, because this system was built for a competition, and it was laser-focused on scoring high on 3 key metrics. The most important one, worth half the points, was recall. Basically, out of all the possible right answers out there, how many did we actually find? The second is precision. Of the answers we gave, were they actually correct? And the third one, NDCG, is all about the ranking. Did we put the very best, most relevant answer at the tippity top of the list? The entire system is a delicate balancing act to nail these 3 scores.
Okay, we've come a long way. The system has found a perfectly ranked list of text chunks. But remember, the original goal was to find the most relevant files. So let's look at the very last step in this whole process.
The system now needs to aggregate these scores. It looks at all the high-scoring chunks that came from the same original document. So for example, file a.pdf had one chunk that scored a really high 0.92. The system just takes that maximum score and boom, assigns it to the entire file. It does this for every single file that had a relevant chunk. And that creates our final, ranked list of the documents themselves. And here it is, the end result. After all that work, the cleaning, the dual indexing, the fusion, the expert re-ranking, the whole system produces this beautifully simple output. It's just a clean, perfectly ranked list of file names delivered in the exact format the challenge needed. From absolute chaos to perfect clarity.